Hey everybody, this is Tim Hart, branch manager of Van Dyke Mortgage here in Fort Myers, Florida. Thanks for joining us today. Today I have a very special guest with me. I'm actually pretty excited and a little nervous because he's a teacher, even though I married a teacher, professor. So we have today the newly promoted associate professor at Florida Gulf Coast University in the Department of Marine and Ecological Sciences. James Douglas. James, thanks for joining us today.
Hi, how's it going, Tim?
Oh, good. Thank you, sir. Newly promoted. You excited about that?
Yeah, it was a big process, but I convinced him that I was worth keeping around. So they must have seen some value in me.
Oh, cool. Good for you. Okay, guys. So the reason why I was able to get James on today is in Southwest Florida, it's no secret, especially if you live here, water quality every summer is a big deal. But this summer is bigger than normal. Anyone that lives here knows it. It's all over the news, and blue-green algae, red tide, and James, it's become so emotional here. There's so much fear, anger. It's political now, health hazards. I mean, you name it, man. This is a huge issue in our area. And so before we really get into it, I'd like to know, and the listeners to know, your background and what you do and how and what you can bring to the table of the conversation. Because what we really need, James, is explanations that are unbiased, right? Not sensationalized, So we just need some good, hardcore, scientific, on a dumb level, okay, answers. So James, first, if you can kind of fill us in on your background, and then we'll start, we'll hit the ground running with these issues, okay?
Okay, thanks, Tim. So I'll start with my science background. I am a marine ecologist, which is a type of marine biologist who studies the whole ecosystem, not just one animal at a time. So I came on this path by studying biology as an undergraduate at Rice University in Texas. And then I got my PhD at the College of William and Mary's Virginia Institute of Marine Science. And my specialty there at the Virginia Institute of Marine Science was studying seagrasses, these underwater plants, which we have in Virginia and we have them in Florida. And I've continued to be a seagrass specialist, but seagrass is an important part of the ecosystem that is affected by algae blooms and pollution, affected by animal life, and it's linked to the ecosystem in many different ways. So I've studied and learned about different types of pollution and different types of environmental influences with seagrass as the focus, but in the process, I've come to know a little bit about a lot of things related to the ocean environment.
Gotcha. So you sound pretty qualified to talk about red tide, blue-green algae, and our ecosystem here in Southwest Florida, right?
When I get to the parts that I don't know, I'll just be honest and say I don't know. So, I'm not an expert in everything at once, but I know enough that I think I'll be able to help your watchers learn a little bit more about the causes and dangers of the problem.
Well, and I think anyone like myself included is going to appreciate I don't know. It's perfectly fine to not know. It's the worst thing you can do is just BS your way, through an answer. And so I appreciate that. So you got anything to add before we jump into this?
I just want to say I appreciate the opportunity. And, it's such a sad thing that's happening now, but I'm excited to be making new connections and meeting more people who are concerned about doing something about these problems that we have. So I really am glad that I can be part of this opportunity to maybe make things a little better than they have been.
Well, the other side note, James, is that, and James is all right? Is it like a...
Yeah, everybody calls me James.
Okay. So. You're going to find out that Southwest Florida, the community here is going to be very active in this. And, they're the fishing community. Well, I host that fishing show called Rates and Reels, which everyone knows I don't really know that much about it. So I go fishing and it's fun. But tons of these captains are so highly involved in it. The people that live on the coast, the people that enjoy the water, lots of concern, lots of citizens that want answers, and more importantly, solutions. And so this is going to be great, man. So I'm ready to go.
All right.
All right. So let's start with the very beginning of this. And I want to talk about red tide, because also, just so we know, we have really, there's two, before we get into red tide, there's really two things we're going to cover: red tide, right? And then the water discharges out of Lake Okeechobee, right?
Right.
Okay. And then how they kind of meet in the middle, and we'll get to that.
Mm-hmm.
So let's discuss red tide first. What is red tide for everyone that doesn't know?
Okay. Red tide is one type of what they call a harmful algae bloom. It's made up of microscopic single-celled algae. And these little single-celled algae are called dinoflagellates. They're a little type of cell that has two tails on it, sort of like a sperm cell has a tail. And even though that they're plants, they can actually move around a little bit with those sperm-like tails. So they're strange-looking little beasts. I've described them as looking like alien sperm or something. And you, of course, you can't see them with your naked eye. You just see a dark brown or reddish stain to the water. But if you look at that water under a microscope, you'll see all of these little red mutant sperm cell things swimming around. And those are the dinoflagellate algae that cause the red tide.
That cause the red tide?
Yeah, well, red tide basically is them. When they're present in a large abundance, it's enough to stain the water red, and that's when we call it a red tide. So there's always a few of those organisms in the water, but it's when they're really thick that they discolor the water, and the toxins that they emit become at a high enough concentration to harm marine life and humans.
What? So then for red tide, what causes it to get thick?
Right. So it's a population boom of those dinoflagellate algae. The particular species of dinoflagellate that causes the red tides we have in Florida is called Karenia brevis. It's named after a scientist named Karen. So in honor of her, they named it Karenia brevis. Although I don't know if it's exactly an honor to have a deadly toxic algae named after.
No doubt.
Yeah, so these little guys are always present in some minute amounts, but when they have the right conditions of light, temperature, and most importantly, nutrients, then they start to grow and divide and divide and divide, and it's an exponential growth because each one of these single cells splits in half, and each one of those splits in half, and it multiplies very rapidly when they have the right conditions with lots of nutrients. The only thing that will stop that population growth is when they run out of something that they need to grow. Usually they run out of nutrients.
Okay, so then you said light. So you mean like more sunlight, the more they'll grow?
Yes, although this red tide algae is kind of complicated compared to most types of algae because they don't necessarily like the brightest light, and they actually specialize in growing in somewhat dimmer waters. And in fact, the murky waters that we have along the coasts of Florida are the perfect environment for these guys, which is what makes them so dangerous when they get in the near-shore murky waters of Florida. They can continue to grow very fast.
Oh, okay. And so then you mentioned temperature as well. So like hotter the water, the more they grow, or?
You know, I don't know the exact optimum conditions for Karenia brevis. There are other algae experts who know more about the particular light, temperature, saltiness conditions. So I don't want to go beyond exactly what I know. I don't think that it's a simple relationship between the hotter it is, the more the red tide blooms. The red tide bloom that we have now started in October, which is not the hottest time. And it was sort of simmering all winter long. So I don't think temperature is really the direct cause for the red tide blooms. Although for other types of algae blooms, they really do respond to temperature, like the other algae bloom. I don't know if we're going to talk about it, the one that's in Lake Okeechobee. that one loves hot weather. So,
Well, is that the one that's coming down the river?
yeah, the green one coming down from the river, that one loves it hot.
Okay.
Red tide, not particularly. There's other factors that affect the red tide.
Okay. Let's get to that. We'll get to the Lake Okeechobee one here in a few minutes. So with the red tide, then you mentioned light, mentioned temperature, and then the last one was nutrients.
Yeah.
And so I've been hearing that a lot. So what are nutrients?
So nutrients are invisible chemicals that make up all life. So the two most important nutrients which are present in all living things and that all living things need are nitrogen and phosphorus.
Okay.
They're two elements. You can find them in the periodic table, and they're found in all living things: humans, fish, algae. And so you and I, we get our nutrients from the food that we eat, but plants, they get their nutrients directly from dissolved chemicals in the environment. So they take the nutrients directly out of the water. And then they use photosynthesis to build those nutrients into their bodies, and that's how they grow and reproduce. So basically, the more nutrients you have, the more those algae can grow and reproduce. And if there's not enough nutrients, then the algae can't increase their populations.
Gotcha. Okay. And so I want to do a follow-up on this nutrients in a second.
Yeah.
How long has the red tide that we have here, how long have we been tracking it? I thought I saw something like the 1800s. It goes back that far?
So there are records of red tides occurring in the 1800s and even before, but we don't start monitoring them in a rigorous scientific way until 20, 30 years ago. So
okay, so we've been measuring it last 20 or 30 years then.
Yeah, and I don't know if it's 30 years or 40 years. I don't know the exact number of years, but we've sort of like continuously improved our scientific monitoring methods. I mean, now we can track it with satellites. We have more boats going out and sampling the water in more places. So it's like we have records of the red tide that go back pretty far in time, but the further back you go, the hazier the records get. Like we don't have as much detailed information on it from way back in time.
Right. It's like someone wrote in their captain's log that a bunch of dead fish showed up everywhere. Like,
yeah, things like that.
So I saw, they're pretty neat to read though, like that type of stuff. So with the red tide then, is this on record? I got to imagine, is this the worst one they've recorded?
I'm not sure.
Okay.
But it's one of the worst, if not the worst.
Okay.
So it's very bad. This is not a normal average red tide. This is one for the record books, if not the worst one ever.
So let's get into then, and also red tide is, in the Gulf, right? Like Texas gets it, other places get it, correct?
Yeah, so that particular type of dinoflagellate named after Karen, Karenia brevis. Yeah, Karen's dinoflagellate, Karenia brevis. That one, they also call it Florida red tide, but it is most often a problem in the west coast of Florida and the Gulf of Mexico. You can find Karen's dinoflagellate in other parts of the world, but it's only in this part of the world, the Gulf of Mexico, that it seems to really be a problem.
Okay. So red tides have been here for a long time, and there's different levels of it. And this is one of the worst cases ever, right? So let's get into why is it one of the worst cases ever, this red tide?
The classic scientist answer is it's complicated, but I can boil it down to it's probably because of nutrient pollution. So that means nutrients that have come from man-made sources running off into the ocean and fueling the red tide. So while there have always been red tides now and then, we think that red tides are becoming more frequent, that they're lasting longer, they're getting bigger, and they have worse, higher concentrations of toxins because they're being fueled by these nutrients from man-made sources.
Gotcha. And so then nutrients, the man-made sources, let's get into that for a second. Okay. So like what are, I mean, you say nitrogen and phosphorus and
Yeah.
like what's going into the water that's man-made that's causing those?
So there's two basic types of things. One thing is fertilizer, which has nitrogen and phosphorus in it. And the other thing is human and animal waste. When the human and animal waste breaks down, it releases nitrogen and phosphorus. So things like runoff from lawns and farms that has fertilizer in it, that's a big source of nutrients. And also seepage and releases from sewage and septic and animal waste releases a lot of nutrients into the water as well.
Okay. And so then let's go ahead and roll this. Let me make sure I check my notes on the red tide.
Yeah.
This is so bad. Okay. So I got my answers there. So then this year, the reason it's being so bad, just to kind of recap, is that red tide always been here, but there's way more nutrients in the water, like a perfect condition for red tide to grow and continue to stay.
Yeah. So it's not necessarily that there's 100 times more nutrients this year than there was last year. The nutrients have been sort of like ramping up gradually more and more every year. And so it's sort of like the fuel for the red tide has been building and building and building and just sort of increasing the odds of a really bad red tide happening. And then whether or not that red tide happens, it kind of depends on the particular ocean currents and things like that, whatever sparks the red tide. And that's a little bit tricky to predict. But basically, because that nutrient fuel has been building up and up and up, we've been sort of stacking the deck in favor of having one of these really big red tides for a long time.
So then there's really not like that, and tell me if I'm wrong, but is there like this one event that happened over the last 12 months that would have like exploded the nutrients into Southwest Florida? Like, you know, Hurricane Irma last year. I've heard that before, that Irma stirred up all of Lake Okeechobee, releasing all these extra nutrients, and then here it comes down the river. Is there anything like that would have happened that was a catalyst for it? Or is it just straight up, it just kept growing and growing and growing and boom, here you go?
Yes. So it's both of those things, right? So it's the keeping growing and growing and growing is an ongoing thing. But Hurricane Irma was a particularly large dose of nutrients from the land entering the ocean. We all remember how much it rained, how much flooding there was, how many sewers and septic tanks were overflowing, how many farm fields had all their fertilizer washed into the ocean. So that was one humongous chunk of fertilizer going into the water. And red tide blooms don't always like start instantly as soon as they have that fertilizer. But the fact that the waters of Southwest Florida had just received a mega dose last summer from Hurricane Irma probably really primed the waters for algae blooms.
Gotcha. Okay. Great timing, Irma. All right. So let's get in. Do you have anything else to touch on red tide before we roll into the Lake Okeechobee discharges?
I could talk about red tide for a long time, but I guess we got a lot to talk about. So if there's particular questions from Facebook about red tide or something, I'll be happy to answer them. Otherwise, we can go on to your next question.
Yeah, I'm looking here pretty quick. I'm trying to scan over a bunch of them, and we'll go live one time and really get them figured out. So I think a lot of it though has to deal with the blue-green algae in Lake Okeechobee.
Yeah.
And in our community, really Southwest Florida, especially Fort Myers, Cape Coral, Sanibel area, Big Sugar and Lake Okeechobee have been, I don't want to say the whipping boys for this whole thing, but they're the ones that are taking the heat along with politicians. And this issue is political now. And it's really hard to find these answers. So as we keep going, I want to thank you for everything you just said. That was lights out, awesome, great information about red tide. I loved it. So thank you.
Great. Well, let's talk about blue-green algae.
Yeah, let's roll. Okay, so why don't you start like with Lake Okeechobee? What is coming out of that lake into the Caloosahatchee that is causing so much problems?
Well, the blue-green algae bloom is actually starting in Lake Okeechobee. And then when the water is released from Lake Okeechobee to the Caloosahatchee estuary, and it's also released to the St. Lucie estuary on the east coast of Florida, the algae basically comes right along with the water. So the algae bloom starts in Lake Okeechobee, but then it continues when that Lake Okeechobee water flows down the Caloosahatchee River into the Caloosahatchee estuary.
And the same with St. Lucie too, right? Same water is going out that way as well?
In 2016, I believe, we weren't having big green algae blooms in the Caloosahatchee, but we were having really big bad ones in the St. Lucie. And this year, we've got it everywhere.
Right. And so what's happened this year that's caused more blue-green algae?
I don't know, but I think it's reasonable to assume that the levels of pollution have just continued to increase since that's been the trend. And it could also be that particular weather conditions we had this spring, hot, sunny weather, could have helped add fuel to that fire of algae growth. So it's a combination of nutrients, light, and that spark of the first algae that are in there to start reproducing, and you end up with one of these big blooms.
So can you, I don't know if you, I'm going to throw this one out there to you, but I don't know if you can speak to this or not, but north of Lake Okeechobee, Orlando, Kissimmee area, that flows right into Lake Okeechobee as well.
Yeah.
Do you have any knowledge of that water coming in? And
well, wherever there's a lot of people living on the land, there's going to be excessive nutrients flowing off the land, because so many things that people do contribute to adding too much nutrients to the water. It comes from our suburbs, from our cities, and there's a lot of those around Orlando. And there's also a lot of farms in the areas around the Kissimmee River. So it's a combination of many sources that add nutrients to the Kissimmee River, which of course flows into Lake Okeechobee. But nutrients don't just get into Lake Okeechobee from the north. They also get in from around the sides of Lake Okeechobee, including the south side, where they have all the famous sugar farms.
Mm-hmm.
Even though the water usually flows from north to south, those sugar farms will pump water from their fields back into Lake Okeechobee, and that's one of the controversial things that adds excessive nutrients to Lake Okeechobee. So there's multiple ways that Lake Okeechobee is getting polluted with nutrients. There's the route from the north, from Orlando and the Kissimmee River, but also there's nutrients coming from the south, and it all mixes together, and the blue-green algae don't care where the nutrients came from. They're going to bloom as long as there's nutrients.
Gotcha. Okay, so with Lake Okeechobee, these discharges, and you follow to see how intense this issue is.
Yeah.
What do you see happening, or what would you like to see happen on those discharges? I mean, you see people send it south, filter it first. Like, what do you think is actually, because the one about sending it south is like, what, 5 years away, the reservoirs or something, or?
I think it's unfortunately further than that away.
Is it? Okay.
Basically, what I would like to see, in answer to your question, is a return to a more natural situation, more natural flow, because there used to be little or no connection between Lake Okeechobee and the Caloosahatchee River. The Caloosahatchee River sort of trickled out before its headwaters even got to Lake Okeechobee. So there never really was much of any connection between Lake Okeechobee and the Caloosahatchee River until about 100 years ago. People dug a canal from the lake into the Caloosahatchee River, and they did that to control the level of Lake Okeechobee, to keep it from flooding over its banks. And it seemed like a good idea at the time. It
Right.
would control flooding. It would allow people to farm around the lake more. Um, they didn't have any idea that it was going to cause a lot of pollution problems. And of course, they did the same thing to the St. Lucie estuary. It didn't used to connect to Lake Okeechobee, but they dug a canal. And at the same time, they built a dam around the southern end of Lake Okeechobee to stop it from flowing south. So now very little water gets south. What does go south goes through special floodgates in the dam. And most of the water actually goes to the east and west. So it's really unnatural, because historically we didn't have any water going east and west from Lake Okeechobee, and we had a lot going south. Now we have very little going south and a lot going east and west. And the change I would like to see would be reverting it back to the natural, sending more south and less east and west. So that central message that a lot of people have been repeating, send the water south, from a scientific perspective and from going back to the natural situation, that really is the central part of what the solution needs to be, in my opinion.
Gotcha. Well, I mean, a lot of people share that opinion as well. So with the blue-green algae that we have right now, the stuff you see in the canals, and especially at like people live in a cul-de-sac, like
Oh yeah,
the canal, I always call them coconut catchers, but like,
yeah,
incoming tide pushes all that water in and it's very hard to get it out.
yeah,
They almost have like a sludge,
right.
in there. So like what's the best way to get that out? Like what's the plan to remove all of that?
I don't know, but some kind of mechanical removal is probably the best bet, meaning using floating booms to whisk it up or suck it up. Because if you try to just sprinkle some poison on it and make it go away, that doesn't really solve the problem, because all the nutrients that algae has soaked up are just going to be released back into the water when it dies, and they'll just cause another algae bloom somewhere further downstream, maybe even worsening the red tide. So just killing the green stuff that's only going to release the nutrients back into the environment, cause more trouble further down the line. So some kind of getting it out of the water is the only option, or just sort of waiting until it uses up its nutrients and drifts away.
I mean, is that like ultimately what you have to do is just like wait? If no one removes it, you just have to basically wait it out?
You just got to wait it out and starve it out. So basically stop putting any new nutrients in the water. Like in the summertime here, there's actually a ordinance that says you're not supposed to fertilize your lawn in the summer.
Right.
I think a lot of people don't know about that ordinance, but if everybody followed that, that would be one thing we could do that would help starve that blue-green algae. There's also things that municipalities could do to treat their sewage and septic better, and that farmers could do to treat their own wastewater better, that would help reduce the nutrient input and would help us starve out the green algae faster, because the sooner it runs out of nutrients, the sooner it'll shrivel up and go away. But as long as it's got nutrients to feed on, it's going to be very hard to get rid of.
Gotcha. Okay, so I want to try. You just mentioned one of the solutions or things we can do to kind of help. But like before we get into that, is there anything you want to add to? And I know you said you talk about it all day, but like with the Lake Okeechobee discharges and the water coming in, did I miss anything that you think would be important to the viewers out there?
Yeah. So I study the Lake Okeechobee discharges and their effects a lot, because they affect the seagrasses that I focus on. So I study seagrasses that live in San Carlos Bay and the lower Caloosahatchee estuary. And those seagrasses need relatively salty water. So even if there's not an algae bloom going on, if you release too much fresh water from Lake Okeechobee, it kills the seagrasses just by the freshness of the water, because seagrasses, they need salt water to survive. So even if there's not an algae bloom going on at that particular time, the amount of fresh water released from Okeechobee is still an issue that affects the environment. And the only other thing I might say is that completely stopping all releases from Lake Okeechobee might not be the best thing for the environment, because during the dry season, we actually do need a little bit of freshwater flow to the estuary to keep some of the ecosystems healthy. And since we've eliminated a lot of the freshwater sources from the natural area around the Caloosahatchee, getting a little bit of fresh water from Lake Okeechobee during the dry season can actually be helpful. So, so there's some fine tuning involved, but basically we got to stop the big overflows and just be much more careful about when and how much water we release from Lake Okeechobee.
Gotcha. And so the one thing when I look at solutions sometimes, and I think it's easy to get deflated or discouraged really quick when, you know, you're just a normal guy and you're like, oh my God, yeah, stop the flow out, you know, east and west. You know, in my mind, you're like, that's way too much. You know, I'm just one guy. And so like, I kind of always boil it down to like, what can I do at my house, you know, or my business within my life to help make this situation better. And when I say this, James, I don't mean like go out and vote, which good, go vote. I'm talking about like within my yard or, you know, wherever you live or work. What can we do in our day-to-day lives that would help prevent this from happening again?
Well, you can go organic in your landscaping and in your grocery shopping. So that means...
And your grocery shopping.
And your grocery shopping, right? So in your landscaping, you don't really need fertilizer. I don't use any fertilizer on my lawn. Maybe it's got a few brown spots and some weeds, but I know I'm not putting any extra nutrients into the environment. And when I weigh the benefits of having a very green lawn versus, you know, having an ecological disaster, I would rather give up the very green lawn and save the environment. So, you know, I got a few weeds in my lawn. Maybe some of my plants could be a little greener, but I'm cool with that because I know I'm not adding to the nutrient problem, which is causing these algae blooms. So I'd say just totally cut nutrient pollution out of your life. So don't buy any fertilizer. If you live in an HOA, maybe you can lobby your HOA to have the landscapers not fertilize or not fertilize so much. So cutting out the chemicals basically is a big one. And then I mentioned the organic grocery shopping because, you know, if we can afford it, it's usually a little more expensive to buy organic food, but we're sort of supporting farming practices that don't use fertilizer. And that's better for the environment and causes less pollution. Because these algae bloom problems, it's not just in Florida, it's everywhere in the world. And, you know, across the United States. So, but the choices that we make in our own backyards, in our own grocery stores, they can help with that global problem.
Gotcha. Go organic and then no fertilizers in your yard.
Yeah. There's another thing I wanted to mention.
Pesticides, same thing, right?
Pesticides are a little different, but I'm glad you mentioned pesticides. Pesticides are things that kill pests, right? And then herbicides kill plants. We want to avoid using those too. And particularly if you've got a pond or a canal or something in your backyard, you don't want to kill by poison or by weed whacking or anything the plants that are around that pond or in the pond. If you've got plants and algae growing in your pond, that's a good thing because they're sucking up the nutrients and breaking down the nutrients before the nutrients have a chance to get further downstream and cause algae blooms. So having a lot of plants and algae in, you know, the ponds in your neighborhood, maybe some people don't like the looks of that, but that's actually a very good thing for sucking up and stopping the nutrients before they get out. So, you know, some people see the ponds in their backyards and the neighborhoods kind of the way they see their pool. They don't want to see any plants or anything in them, and they hire people to come and put dangerous chemicals like copper sulfate in those ponds. What that does is it kills all the plant and algae life in the ponds, and it releases the nutrients, which then flow out of the ponds and get into the rivers and cause these algae blooms. So basically, we want weedy, scummy ponds to avoid having algae blooms in our rivers and oceans.
So, but the pond that's whatever, 10 miles away from the river with no canals around it, even that will affect the river?
Absolutely, absolutely. All of the algae bloom problems that we have in the rivers and the ocean, they start on land with what we're doing on land. Anywhere you are on land, doesn't matter how far you are from the ocean. If you spill some nutrients or fertilizer or pollution on the ground, it will make its way to the ocean because all water flows downhill. It may take a while to get there, but it's going to get there. And your pond has an overflow thing. It overflows and goes out into a pipe. It goes into a canal. The canal goes into a river. It really doesn't take that long for the water from your little pond to get into the ocean. And if you've mistreated that pond by putting poisons in it or letting fertilizers get into it, then those things are making their way into the ocean and contributing to the algae blooms. So, the ponds, they're not even supposed to look like, reflecting pools. They're supposed to look like weedy wetlands. And being a weedy, shaggy wetland, that's when you know they're working and they're really stopping the nutrient pollution. So I think one of the best things that we can do is not expect our ponds and things to look like perfectly tidy, golf course ponds or whatever, but expect them to look more like shaggy wetlands with lots of plants in them, because that's when we know the nutrients are really being sucked up and stopped by the plants.
Gotcha. Yeah. Man, that was a lot of stuff.
Sorry, I kind of went off. I really like plants, if you haven't picked up on it. But, plants are, one side of stopping nutrient pollution is just not putting the nutrients in the water. Mm-hmm. Once the nutrients are in the water, plants are one of the best way to get the nutrients out of the water. So having the water run through like a wetland or a special artificial wetland that has lots of plants in it, those plants will suck out the nutrients and disintegrate them, basically.
Gotcha. Well, yeah, that's what happens when it used to flow south, right, through the Everglades, and all the plant life, everything would just eat it up, and then it just flows out to the Gulf.
Totally. I mean, the Everglades is so big that it's sort of the only wetland that's big enough to deal with the magnitude of the pollution problem that we've created.
Gotcha.
That said, there could be some problems if we just dumped all the really polluted water straight into the Everglades. And so what our plan is, what the scientists want to do is turn some of the sugarcane fields into sort of like pre-treatment wetlands. So the polluted Lake Okeechobee water wouldn't go straight into the Everglades. It would go into the pre-treatment wetlands and then go into the Everglades. And that way it would be semi-clean before it got into the Everglades, and that would help keep the Everglades more intact.
That's a plan that FGCU proposed, or just a bunch of scientists?
No, that's a plan that lots and lots of scientists have proposed, and it's part of the, what do they call it, Comprehensive Everglades Restoration Plan, for buying out a lot of the sugar land and turning it into these artificial wetlands that would clean up some of the pollution from Lake Okeechobee and then pass it on into the Everglades. So it's
but that's the plan, though. You're talking like 2029, right? Like,
well, it sort of depends on who you ask. I'm in danger of getting into the political part that I know everybody's very frustrated with, but there's a tendency.
Feel free, man. People, you earned it, so speak freely.
So some people make it out to be harder than it needs to be. So, and they don't want to do it. Like they don't want to give up the sugarcane fields and stuff. So they're like, well, we can't do that. Or, they're sort of like a pretty bold proposal originally to get a lot of those sugarcane fields and make a big wetland soon. And the trend over time has been, well, actually we got to wait a little longer, and we're going to make that treatment wetland a little bit smaller and smaller and smaller. And pretty soon it's going to be like a tiny little wetland that's not going to be built for 100 years. So it's sort of like we just have to kind of bite the bullet and say, we want to do this now and we want to do it big. And, I think some of the emotions and things that people are going through now, maybe that's the impetus we need to get people to take some big action.
Right.
So, I know it's tough. I'm always cautious when people get so fired up about something. There's a big danger of, misunderstanding the issue or causing more problems than we're actually fixing. But, if we can keep it together, keep a consistent theme, keep listening to the scientists, tooting my own horn there a little bit. Maybe we can channel some of the hurt that people are feeling now into actually fixing the problem.
So I kind of I didn't say it in jest earlier about, hey, go out and vote. And I would never tell anyone really who to vote for. I always just educate yourself and vote for who the right fit is for you. But what is all these people that are concerned, right? So you got your stuff you handle in your house, in your yard, and you're doing all these things you can do. But who can they put the most pressure on with emails or letters or phone calls? Is it federal? Is it state? Is it FWC? Or who takes where should they direct their responses to get the best action?
The state government has the most control over these problems that we have here. So, there is a role of federal government and getting federal funding for some of the restoration projects. They could contact Senator Nelson or Senator Rubio about that to encourage them to, allocate funding for the creation of the wetlands that will filter and store the water. So that's something they can do. They can contact their federal level guys, but the state level is huge. And the governor of Florida has an enormous amount of power for good or for bad over the environment, because the governor dictates what the Florida Department of Environmental Protection does and what the Florida's 5 water management districts do. And those water management districts, they're the ones that direct all the water flow, which way the releases are going. And the governor ultimately has power over that, because he decides who the bosses of the water management districts are and whether they're going to manage the water flow for environmental reasons or to protect certain industries or for some combination or balance. It's really up to the governor. So, the governor's race is a very important one in Florida.
Okay. And then you got a state Senate, House. So not as much pull as the governor, but still important?
Still very important. I'm a scientist. I'm not a political scientist. But what the state senators can do for better or worse for the environment is pretty huge. So it matters who your state senator is. And so look them up, look up their environmental record. It's easy for the federal positions, because there are websites where you can see how many environmental laws that politician has voted yes for versus no for. There's one called the League of Conservation Voters, where you can see how many times has Bill Nelson voted yes on an environmental law, how many times has Marco Rubio voted no on an environmental law.
Right.
They break it down year by year. So you can get a lot of that information for the U.S. senators, but for the state level, it's a little harder to find. You kind of have to do your own internet searching. And you got to be careful on the internet, right? I mean, sometimes you can run into some biased information, but we're doing
That's
we're
an,
doing our
that's an
best, right?
understatement.
We're doing our best to get some good information out there.
No, and this is perfect, man. James, I really appreciate it. I think we got enough time. That was a lot of information that you came to us with. And I can tell you, I was kind of glancing over at my Facebook once in a while, just looking, and they're blowing it up with questions. And so maybe down the road we can do a little Facebook Live thing and take some questions. You down with that?
I'm up for it.
All right. I'll get with you on that, though. So, guys, this was kind of an impromptu thing. Kind of came together last minute. Wasn't too planned, but man, I'm super thankful, James, that you jumped on, was able to do this, and I hope people out there get some knowledge from you. He has a blog. He's been posting some stuff in there as well. I'll put that article, that algae article you wrote, I'll put it in the
Awesome.
comments so they can check that out as well. Okay.
Sounds great.
All right. Well, this has been the newly associate professor, James Douglas from FGCU. James, I appreciate you being with us, buddy. Anything else you want to say?
Well, Tim, I hope that we get through this and you start catching fish again soon.
I hear you, man. Well, James, thank you very much. Appreciate it again. Take care, and thanks, everybody. Hope you enjoyed it.
Take care.